Okay, here I'm going to measure the dowel pins that register the pin knives, and they are threaded on. They are a hardened pin, and they are replaceable if they get knackered. Okay? What I'm going to use to measure them with is a Matoya micrometer that is accurate to within 0.001 millimeters. Okay, so let's check it for let's check the clutch and see if it's actually set. Look at that, it's perfectly set. Always hits 0. Okay, so let's start off by measuring a sheet of paper. Some people have a hard time understanding how big something is, and when we're talking about these big numbers that look like big numbers, let's compare them. Okay, let's focus in. Okay, so looks what we got here. The paper is 10, 11. It looks like it's hitting on the 6. So the paper is 0.116 millimeters. That's how thick a piece of paper is. And it's not this particularly heavy cardstock. That's a standard envelope paper. Okay? Now, the pins, according to the manufacturers, are 6mm pins. Dowel pins are probably the most accurate registration. If you're a machinist, you know that. Now, dowel pins cannot be larger than their specified size, and these are specified dowel pins of 6mm, which means they can never be larger than 6. During manufacturing, there's always, for parts that fit to each other's, the accuracy is either plus or minus. In the case of the dowel pin, it would have to be minus. Now that tolerance, in other words, how much tolerance is the manufacturer allowed, can be different all over the place. So we're going to measure the tolerance of this dowel pin, which is supposed to be 6. Now, as you can see, we've got it in there. So, we can see that it is 1/100th smaller. 1/100th of a millimeter smaller. So that would be 0.010 smaller than 6 millimeters. Now, for measuring bores, the most appropriate tool is to use gauge pins, which are certified. Matt has a set, I don't. So I'm going to use my machinist drill case, which has number bits, letter bits, and fractional bits. And I have found that the C bit fits into the knife very accurately. Matt will have to register this. We're talking microns, okay? So this is a snug fit into the bore, so let's measure that. Okay, and so that will give us the tolerance of the bore, which has to be bigger than 6. That's just basic machinery standards. So we'll do it. We'll focus in here, and we can see that it is 4. 4 let's see what lines up. 4. Let's see what lines up there. Just trying to focus. Okay, so it's 4's not there. It's a little more than 4. Looks like 4.4. So this pinhole is 0.044 millimeters bigger. This one is smaller. Okay? So now, what is the slop? Well, the slop would be this number added to this number, which would give us, it's going to give us 0.054 millimeters of slop. Okay? Now, let's look again at the thickness of paper. And that's the thickness of paper, 0.116 millimeters. That is the slop. Okay? And when we talk about accuracy of knives being set, we generally are working in thousandths of an inch, but some people will work in metric, and they'll say 0.1 millimeter is accurate for setting knife. This equals 0.004 thousandths of an inch. So as you can see, the accuracy that most people register their knives to is approximately the thickness of paper. And the accuracy of that bore is less than half. The accuracy of those bores together are less than half the accuracy. Okay? Or in inches, approximately 0.002 thousandths of an inch. 2 thousandths of an inch. That's pretty accurate. That is far more accurate than braze tooling, and probably amongst some of the most accurate machining done. And this is perhaps one of the cheapest heads you can buy. So I would make sure that when people tell you that they're garbage and they don't register properly, they aren't really got any facts. They are just reading documents from other people and actually aren't putting stuff on a setting gauge or measuring it with proper machinery. And even here I'm not measuring with proper machinery. If I use dowel pins, Matt could tweak that in. But still, we're talking about adjusting this little number right here. The accuracy I'm working in is here. Okay? Matt could bring us to the next digit and make that even more accurate. But that is the accuracy of the pins. I also put the two knives together with two C-bits sliding together to see the accuracy of the spacing. But obviously, the knife slides onto the pins in the head. It's not a big deal. So that's how much is needed for slop, which I could tell you is virtually nothing. It's 0.002 thou. It's 2 thou of an inch. It's 2 thou of an inch, or half of what insert tooling is to be set accurately to, 0.1 millimeter, which is 4 thou. So anyway, I hope that didn't aid to confuse you, but only give you the facts.